Hello, everyone, and welcome to the Clean Energy Prize at MIT's 13th annual, but first ever virtual finals. My name is Monica Hernotto, and I'm one of the managing directors this year. First off, I'd like to start by saying that I am really proud. I'm proud of our finalists for saying yes to every new and sometimes last-minute request that we made as we were virtualizing the event. I'm proud of our mentors for helping them adapt. I'm proud of our sponsors, the Massachusetts Clean Energy Center, Morrison Foerster, Novartis, the Innovation Incubator, and the MIT Energy Initiative for supporting and encouraging us to move forward with the prize this year. And I'm proud of our leadership team for the hours of work that they've put into making today happen. I'm also really proud of our judges and for all of you for showing up today and signaling that clean tech entrepreneurship is still a top priority. So thank you. At stake today is our runner-up prize of $10,000 and feature on the MIT Energy Initiative podcast, and our grand prize of $100,000 and features on both the My Climate Journey and MIT Energy Initiative podcasts. So turning to our agenda, you can see that our next few hours are action-packed. We'll start off with a few words from two of our biggest supporters, MassDC and Morrison Foerster. And then we'll jump into our pitch rounds, which will be 5 minutes of live pitches and 10 minutes of Q&A from our judges. Then you'll have 2 minutes of uplifting music for you to listen to as all of our judges fill out their score sheets. For the pitches, we'll have Sophia from our leadership team give audio cues at 5 minutes and 15 seconds, and the team will have to wrap up in the next 15 seconds. For the Q&A, Sophia will also be giving audio cues at 1 minute remaining, and we'll call time at 10 minutes. We'll hear from Circe Industries, Contraire, Harmony Water, and then Nitricity. At 4 p.m., the judges will leave to deliberate, and you all will get the opportunity to hear from and ask questions to two of our alumni founders, Dr. Matthew Silver, who is the founder and CEO of Cambrian Innovation, and Elise Stroback, who is the co-founder and CEO of AeroShield. She's also our grand prize winner from last year. Then at 4:25 p.m., it'll be time for the big announcement, and we'll be awarding both the runner-up and grand prize winners. So now we'd like to take a moment to hear a few words of encouragement from MassDC and Morrison and Foerster.
Energy Prize finalists, all the applicants, semifinalists, and the Clean Energy Prize team for organizing your competition and these finals virtually in what are clearly really challenging circumstances. You know, I just rode my bike downtown, and of course it's deserted. It's like a ghost town down here. And obviously that's due to the impact of COVID-19 on our economy. You know, I heard the other day that emissions are actually projected to drop by over 5% this year due to the downturn in the economy. And curiously, that actually puts us on target to meet the Paris Climate Accord. Actually, emissions would have to drop by about 7% annually for us to achieve the Paris target. So it's a very strange way for us to learn what is necessary to decarbonize our economy in order to meet our climate goals. But it is a real wake-up call and a reminder of how important innovation is in that fight. So to all of the Clean Energy Prize finalists, applicants, semifinalists, mentors, and other supporters, we know these are really, really challenging times, but I also know from my years of working in this space that there is an incredible community of really supportive people, from investors to incubator leaders to public and private sector climate change advocates, early adopters, customers, and others who stand ready to help you take the next steps as you develop your clean energy or climate change solution. So the Mass Clean Energy Center has been a really proud supporter of the MIT Clean Energy Prize for about 10 years, actually. We've seen a a really wide variety and healthy number of very promising startups emerge from the competition. And that's why we've been really proud to support it. And we're also really privileged and happy to have some funding opportunities, competitive funding opportunities, to help you take the next step as you commercialize your clean energy or climate change solution. You can learn more about those funding opportunities at our website, on our website at masscec.com. So whether, fighting COVID-19 or fighting climate change, innovation matters, right? And we've got innovators across the region who are trying to develop a vaccine for the coronavirus, to manufacture personal protective gear in a rapid fashion to get more tests out the door. But not all of those efforts will succeed. Innovation requires risk. And similarly, not all the innovators working on climate change solutions will succeed. We need many shots on goal, as they say, if we're to meet our climate change goals. Innovation involves risk. So we don't just need one vaccine to cure climate change, right? We need dozens of vaccines. We need long duration storage. We need new lightweight materials for electric vehicles. We need to decarbonize heavy industry and agriculture. We need to figure out how to integrate hydrogen into our economy. We need to dramatically reduce our dependence on natural gas. We have to develop scalable and replicable models of retrofitting millions of existing buildings. So we have a whole slew of really tough challenges. And then on top of that, we need to develop new innovative business and finance models to dramatically scale up the pace of adoption, the pace of our efforts, if we're to flatten that GHG curve and have any chance of achieving our long-term climate goals. So we don't have a lot of time. We have a decade or so to figure out what all these solutions are, and we need to start implementing them and piloting them and testing them even sooner than that. So we're depending on all of you to continue to generate the great ideas that you do. We want to be supportive of you if we can. I'm confident, given the community of innovation that we have here in the Northeast, that we'll get there, just as I'm confident that we'll overcome COVID-19. So let's support each other. Let's certainly support all the emergency medical personnel and medical professionals who are working really hard every day to keep us healthy and safe. Let's give thanks to all of the essential workers who are keeping our economy moving. But let's keep our eye on that long game and stay focused on developing these critical clean energy and climate change solutions. So good luck, stay healthy, and best wishes to you all. Bye-bye.
My name is Anita Choi. I'm a partner in the San Francisco office of Morrison Foerster, and we are a proud sponsor of the MIT Clean Energy Prize. My practice is focused on patent prosecution and patent diligence, and also support patent litigation across a wide variety of technologies with a particular interest in clean technology and renewable materials. Morrison Foerster has supported the MIT Clean Energy Prize for many years now, bringing together students, entrepreneurs, academics, and industry experts to begin identifying and addressing energy opportunities. We at Morrison Foerster understand the rapidly changing landscape of renewable energy and clean tech, and are honored to deliver innovative legal counsel to those who are scaling renewable energy and driving the transition to sustainable solutions that decarbonize the global economy. We have more than 100 clean technology lawyers around the world, from California to Washington, D.C., London to Berlin, and all across Asia, who stay ahead of the curve on regulatory developments and investment trends to maximize your business potential. Climate change touches every person on this planet, and to combat its effects, this next decade will require doubling down not only on the financing and development of clean and efficient power generation assets, but also on investment in new technologies and new infrastructure. New technologies and infrastructures that value flexibility, reliability, and resilience. I am constantly inspired by the dedicated entrepreneurs that I work with on a day-to-day basis, and here today, whom are facing the world's most pressing issues with unprecedented innovations. So thank you to all, and best of luck in the finals today.
Thank you, Matthew C. and Morrison Foerster. Now I'd like to introduce you to our finalist judges. Tracy Gray is the founder and managing partner at the 22 Fund, founder of We Are Enough, and executive in residence at the Los Angeles Clean Tech Incubator. Carrie Bowie is a managing partner at Masada Partners and an MIT alumni. Jason Jacobs is the host of the My Climate Journey podcast and was the founder and CEO of Runkeeper. Ariel Horowitz is a senior program director at the Massachusetts Clean Energy Center and has previously worked at Synapse Energy Economics and Project Drawdown. Finally, Mike Ward is a partner at Morrison and Foerster. Welcome, judges. So without further ado, I'd like to invite Circe to turn on your video and audio, and we'll start the timer as soon as you're ready to pitch. Thank you.
Thank you all. I'm Shannon, and we really appreciate you all giving us this opportunity to tell you about Circe. We are an early stage team of scientists and engineers that are committed to circularizing industries with cellular factories. And one industry in urgent need of circularizing is plastics. Plastics are everywhere. They're very much not going away. They are not just filling up our homes, but are accumulating in our landfills and environment, and their production is a heavy emitter of greenhouse gases. While there have been attempts to address these problems with bioplastics, the big question is, where are they? Until now, they haven't been as versatile or as cheap as petrochemical plastics, and depending on their process, they have their own sustainability concerns. We are working to change that. Synthetic biology gives us access to new polymers not possible through traditional chemical methods, and it is this genetic engineering of microbes that form Circe's core IP. Our versatility is born out of the complex chemical space available to these polymers. This graph depicts the variable material properties of common plastics, and our IP enables exploration of this space. Until now, the inputs for these materials have been limited to plant oils and sugars, and those both have a high price, high volatility, and large carbon footprints. We're using CO2 and methane as feedstocks to lower our costs. And because bioplastics are made of greenhouse gases and can biodegrade in the environment, we can support a more sustainable future with our system. In addition to decreasing costs, using gases to build our materials reduce their carbon footprint compared to polypropylene by 72%. And by 2050, our system allows us to offset carbon emissions by almost 1 billion tons if we can achieve 20% market capture of polypropylene. So as a testament to our versatility, we can enter many markets. Starting from the lower left and moving through personal care ingredients, we can expand into larger markets through early revenue generation and ultimately into consumer goods. As we scale, we take advantage of gas fermentation technology that allow us to enter markets that traditional bioproduction cannot. So in order to achieve our long-term vision, we've selected a beachhead market in personal care. This is because we've identified a problem there. Consumer demand has created a strong push away from petrochemical ingredients, and this has left brands with inferior products. So we are producing clean, sustainable, and functionally superior ingredients to address these customer needs. Given this strategy for our beachhead and assuming 6% capture of personal care polymer market by year 6, we've created a model that shows we are able to generate revenue early on. We are uniquely positioned to execute on this strategy because we have the versatility of sophisticated symbio companies, the scalability of chemical companies, which enables us to produce our products cost competitively. In the past few years, we've focused on the engineering of these microbes that can use CO2 to make these polymers. And currently we're working to increase productivity by development of a gas fermentation system. We're also formulating new prototype materials, and we're forming partnerships that will allow us to rapidly scale up so that we can quickly sell our products. Together, we combine the expertise in biology, engineering, and business development, and have the determination and know-how to pioneer our new bioeconomy. Thank you.
Thank you, Circe Industries. You can stop your screen share now. And then judges, please turn on your videos. Okay, thank you. Judges, you have 10 minutes to ask any follow-up questions.
Sorry, go ahead. I wanted to see if, your financial slide again.
Oh, can I reshare my screen?
Yes, go ahead.
Yep.
So 6 years is quite a long time to get to 2.7 million. Can you explain your ramp up to that and why it isn't a greater ramp up?
Yes, so I'll pass this over to Kevin to give you a full explanation.
Yeah, sure. Thank you for taking the time today. And the financial projections that we have at this point are quite conservative. This is looking at a 6% growth or capture, as Shannon said, of the existing market over a period of scale up in production from about 500 liters to 20,000 liters. And that's based on similar business models that we've seen in industry. And so within tough tech, getting to production scales beyond 20,000 liters tend to take those sort of timeframes. And we are not estimating additional growth in the market that we may enable, nor are we trying to have sort of overestimates of the market capture that we could get within that time frame. We're basically trying to demonstrate that our system has financial viability in the early years to enable us to expand and really take meaningful market share as we scale up.
Hey, this is Kerry. Sort of going back to just sort of the base, and when you talk about things you've seen in the market, sort of a question about your competition. And so I think I understand the difference between plant oils and CO2. So I think of folk like Metabolics, Agravita, Ginkgo Bioworks. In the CO2 space, is this similar to what, say, a Coverty is doing? And why is your value prop better than theirs?
Yeah, so because you know Coverty, I'll compare ourselves directly with them. So yeah, we're doing similar processes in terms of what kind of products we're able to make. Both Marika and I are synthetic biologists, have been working exclusively with this microbe to genetically engineer it for the past few years. Coverty doesn't quite have that genetic engineering capability. So they're using a lot of just kind of the wild type materials. The other advantage that we have is we are planning to partner with Lancetech and Ginkgo to allow us to scale quickly and build upon their existing infrastructure in a kind of asset light approach. So our scalability, the extent of our genetic engineering, and our partnerships will allow us to differentiate ourselves.
Thank you.
I had a question around your assumptions on the CO2 sort of cost and availability. Are you planning that as you scale up, that would be CO2 from direct air capture, or is that not important to how you are thinking about GHGs?
So yeah, we actually have a few different models. So I can So a few different models, and we haven't committed to a particular strategy as yet. So if we were to take all of these processes into account, the carbohydrate forms of feedstocks would have the cost of goods for a kilogram of our material to be almost $5, which is a non-starter. But by using gases, even at $200 a ton, which is kind of the accepted average for CO2, we're able to lower those COGS quite a bit. And then if we are in a location where we either get a carbon credit or there is a carbon tax, then we can kind of adjust our COGS in that way. But yeah, we both need to determine what scale we will be at to know which point source to co-locate with in order to really fine-tune the cost of inputs here.
Sorry, Ariel, I think you're still muted.
Sorry, but at the moment, your plan would be to sort of procure from any other type of bulk gas supplier. Is that correct?
Like air gas?
Right, like an air gas or an air liquide.
Right. So in our lab scale, we plan to, we're currently using air gas, but we currently want, or in the near future, we want to actually take the gases from a variety of point sources just to see which impurities, which concentrations of gases are most productive for us so that we can guide what point source we will co-locate at initially. So we do want to have within the next few years a pilot co-located with a carbon and hydrogen source.
So a couple questions from me. This is Jason. One is just how capital intensive is this type of business to scale, and what are the right sources of that capital beyond seed? And the second is, are there any future policies or regulations that need to be in place for the math to work that are not currently in place today?
Yeah, I'll hand that to Kevin.
Yeah, sure. So I think we have a slide that sort of shows some of the capitalization. Is that true, or did that not make the deck? No, I guess it got.
No.
So we were looking at a variety of scale-ups, and I believe those numbers, Shannon, could you, what was our Series A round that we were looking at? Is for
Yep.
dollar value?
Oh,
do you have that on hand by any chance? Oh, okay, there it is. Yeah, 15 million. It was on that slide. Yeah. So the initial scale up that we're looking at for pre-seed into seed is about $4 million, and then the Series A, which will take us to that on-site pilot that Shannon was just talking about, and up to the sort of year 6, 20,000 liter scale is about 15 million. Beyond that, we would be looking to go commercial, which is between 200,000 liters and 500,000 liters. And companies are doing that scale right now with gas fermentation, such as LanzaTech. And so funding rounds similar to what they've raised would be sort of the expectation. In terms of the policy.
Actually, before you get to policy, can you just talk a bit about the sources of that capital and the return expectations?
Yeah, so we've been speaking with various both venture capitalists and tough tech investors. And we think that we've met a lot of like-minded people who understand the capital intense nature of such tough tech to market approaches to sustainability. And we've gotten a lot of interest from those folks and sort of pursuing what funding they could help lead alongside of us, and looking at sort of the marketing strategies for bringing these polymers into the beachhead that we've established and then transitioning to the other markets that we've identified as viable from there. Onto the policy question, while there isn't any specific policy that we need to make this viable, having carbon taxation is a benefit to us. And we believe that sort of the pushback against single-use plastics is a place where we could actually work with regulators to enable lower cost biodegradable alternatives to the existing single-use plastics. As we've seen with COVID-19, the reusable bags have gone back to the single-use plastic bags. And for example, we believe that we could be a replacement that is environmentally sustainable and also achieves the objectives of sort of, reduced transmission in such a time as we have now.
Thank you.
Time is up.
All right, thank you, Sophie Industries. Please turn off your cameras, and judges, you have 2 minutes to fill out your score sheets. All right, 2 minutes is up. I would like to welcome Contraire to turn on their videos, and we'll start the timing as soon as we get started.
By revolutionizing wastewater monitoring, Contraire can help mid-sized towns and cities save over $250,000 a year in energy savings with no upfront capital. So to treat wastewater, we pump lots of air into it to degrade the organic matter. And that's what you see in the top right picture. The air gets there through diffusers who get their air from mechanical aeration blowers. These things are about as tall as an NBA player and twice as expensive. They take up about 75% of the total energy going into these facilities. So the problem with wastewater treatment is it's as energy intensive as it is important, and the main parameter that governs these facilities is a 5-day biological test for organic matter. So this one parameter causes, and the lack of water data causes operators to over aerate as standard industry practice just as a precaution. And we have really good data on this. This is from our town of Stillwater, Oklahoma, with around 50,000 people. The top plateau line is the government regulations on organic discharge, and the bottom jagged is what was actually being emitted from the plant. This green area comes from over-aeration and lack of water data when it's needed, causing a small city to spend around $300,000 in excessive electricity every year with and that's without any demand-side management benefits. So our solution to this widespread problem takes 9 industrial-grade wastewater sensors, each measuring their own water quality parameter, and these sensors will feed their outputs through our algorithm that not only gives a real-time estimation of the amount of organic matter present, but it also adjusts those mechanical aeration blowers accordingly. So currently we are in the lab, having just completed a 17x reactor upscale and wrapping up our bench scale algorithm development. We've completed over 50 in-depth market analysis interviews, as well as NSF I-Corps program and VentureWell Phase 1 and Phase 2.
There were over 16,000 wastewater treatment plants in the United States alone. Most of these were built between the 1960s and 1980s and have had little to no upgrade since. This is important to note because our retrofittable There are over 16,000 wastewater treatment plants in the United States alone. Most of these were built between the 1960s and 1980s and have had little to no upgrades since. This is important to note because our technology is retrofittable with these companies, with these wastewater treatment plants. As a result of the NSF I-Corps program, we were able to identify the most energy inefficient plants as plants to serve municipalities with a population of 10,000 to 100,000 people. Further, we will target activated sludge treatment processes and plans to use variable frequency drive motor controls. Our total addressable market will consist of 7,700 wastewater treatment plants, and that results in a market value of $370 million annually. The reason our market value is recurring is because of our unique pricing structure. Contraire will charge a base fee plus a variable fee dependent on that particular wastewater treatment's flow rates. This pricing structure was developed as a result of customer discovery interviews and will ensure even pricing throughout the entire industry. The low-cost subscription model will simplify the purchasing decision because the economic buyer, the city manager, can sign a lease contract without going through the long government procurement process of a capital project. The deployed sensor control systems will remain under Contraire's ownership, which results in month one savings for the municipality at no upfront cash expenditures. With an average price of $48,000 annually, Contraire produces a net economic value for our municipal customers of $252,000 a year. Additionally, this pricing structure allows for a corporate payback period on deployed assets of about 8 months. Additional benefits include demand-side management, which is using less electricity when electricity production is at its peak, significantly reducing indirect and direct greenhouse gas emissions relating to treated wastewater, and extending the life of the mechanical aeration blowers Rebecca previously spoke about. Rebecca and I are the two co-founders of Contraire, and although we're focused on building a profitable business, we also want to have a profound environmental impact. In order to fully launch Contraire on a national scale, 3 rounds of funding will be raised in the total amount of $5.3 million. This capital will predominantly fund common operational losses as well as the deployed sensor control systems, which fundamentally are revenue-generating assets. In year 7, we will be in approximately 500 wastewater treatment plants and generate revenues of $22.5 million. Although our technology is novel, we are not without competition in the wastewater industry. However, these listed companies predominantly focus on municipalities with a population of over 1 million people. No company offers a competitive advantage of a unique water predictive analysis of key water metrics, retrofittable at no upfront capital cost. We predict an exit value of $90 million in year 7.
In conclusion, Contraire offers investors an attractive risk-return ratio in a recession-proof industry. Treating wastewater takes 10 times the amount of energy as treating drinking water, and we believe our energy-saving water monitoring innovations can save both municipalities and electric utilities capital and greenhouse gas emissions. Thank you, and we look forward to answering your questions.
Thank you, Contraire. Please stop your screen share and judges turn on your videos. All right, 10 minutes starts now.
I have 2 questions. One is, how do you plan to approach validating that the analytics are actually getting you the aeration results that the plant is looking for? And do you anticipate having to revalidate this on a plant-by-plant basis? And then the second question is if you could elaborate specifically around the question of peak savings versus energy savings.
Yes, absolutely. For validation of our analysis, the operators already have to do the old school 5-day biological test. So they will be performing these tests in parallel to our sensors giving a algorithmic estimation. So we will actually have, once we implement fully into beta testing, which we have agreed upon from our local operator, that we will be able to compare our data analytics to what they got in their old school method of BOD analysis. And then if you don't remind, what was the second part of the question? I'm so sorry.
So you're claiming peak savings, but your unit was in energy savings. I can definitely see how you would lead to energy savings, but is there a specific thing around peak management?
That will be explored once we implement fully into beta. Right now we're still in lab scale, but what we hope to do is be able to aerate less during peak energy hours and a little bit more during nighttime and whenever energy is cheaper. So yes, definitely I put wrong wording on the slide, my mistake.
So Rebecca, so in a sense, I've got a couple questions. So is this product or is this service? It sounds like it's a passive sampler, sort of, you know, a sipper or a peeper, you know, to actually have information. So that's one question. The second question is, so they're doing the old school method of 5 days. And you know, I know you said this is recession proof, but it's also municipal. So what's the sales cycle? You know, if they still have to do 5 days, you know, when you bring in your new technology, do they still have to do it? And so if they've got to do both, why, you know, even from a regulatory perspective, why would they use your technology?
Carrie, will you say the first part of your question one last time?
It was more product or service.
Oh, yeah, we definitely consider ourselves a service, and we will be offering ongoing customer service throughout the life of the contract. And then the second part, they will be continuing to do the 5-day biological test, but in parallel, they will also be taking our metrics of the water quality. So they're going to have to clean the sensors to prevent biofouling. Will you, Rebecca, do you have something to add?
Yes, absolutely. They are aerating pretty much at full capacity consistently. So rather than a expedited bureaucratic process for having their quantification of biological matter, we are providing more of an energy saving service. So the main value proposition is not really to be able to have our sensors replace the old school BOD test methods, but rather have our sensors assess the water quality and then make a decision on whether or not the mechanical aeration blower should turn up, higher, or lower. I hope that answers.
And our algorithm is able to tune into however the margin of safety of whatever the wastewater treatment plant manager wants. So if they want to be closer to the legal limit, we can do that, but it's enabled to build trust initially with the customers. We can have that margin of safety higher and aerate more to make them feel comfortable with our product and service.
I have a question around the savings that you described on that small plant. I believe you said they saved about 300K. But is that, when you quantify this for a potential customer, is there a percentage based on size of the municipality and the wastewater plant? And do you have that number?
Yes, so, and that was not implemented savings, that is theoretical, but it was based on pretty much how much they're over aerating, which we found to be uniformly 45%. And then we compared that, because that was a local study that was done by me and my lab mates. And then we compared it to literature values across the country, and that was that, and honestly across the world, and they all seem to say that overall operators tend to over aerate by about 45% uniformly, regardless of size.
Number, the percentage, is there a percentage of the dollar number their savings? I'm a little confused about.
Oh, okay.
It'll be 40. So currently wastewater treatment plants, about 75% of their total capital cost go to these aeration blowers, and we'll cut that 75% by approximately 45%.
Okay, that's helpful.
Okay.
Sorry.
Hi, this is Mike Ward. You mentioned that your algorithm is proprietary. Can you speak to the proprietary nature of it and how you're going to prevent others from simply designing around your algorithm? And
Sure. So our technology, like you said, is an algorithm. So we haven't, there's no final decision on if we're going to file for a patent or keep it under copyright law. Ultimately, the technology is owned by Oklahoma State, so they will be making that final decision. They have obviously experience in doing this, as well as countless lawyers, so they have a strong team to make that decision. But we do realize that algorithms can be duplicated and reverse engineered and all that. So we really want to create barriers to entry after taking advantage of first mover advantage. So a couple of ways we're going to do that is sign a multi-year contract, as well as there's cybersecurity plays on key infrastructure in the United States. Right now, wastewater treatment plants, some of them are potentially places to be attacked from cybersecurity. So that is potentially another barrier to entry that we could implement, as well as going to the power authorities and getting the power authorities on our side and having them sell the product and act as a champion for us in our sales cycle.
I've got one follow-up if Tracy or Jason aren't jumping in. Back in 2008 in the economic stimulus package in the Obama administration, there was a green infrastructure sort of set aside where I think most municipalities had money to go and do a lot of energy saving. So are you telling me that most of them didn't do that, or is there a certain size that you're targeting? Because my thought would be they went and probably tackled a lot of these energy savings back then.
So we're focusing on plants that serve a population of 10,000 to 100,000 people. So they're underserved communities. And then Rebecca, do you want to tackle the technical side of that?
Yes, there's an intellectual disconnect between those that are actually signing the energy checks and having to pay the bill as compared to the operators of the wastewater treatment plants. So what we found in our I-Corps interviews, where we had to interview city council members, city managers, our mayor, and like the operators and people who work at the plants. And what we found is they don't often talk to each other, and people who work in the more bureaucratic side of the government are unaware of these potential optimizations within the wastewater. They don't have a common knowledge of wastewater treatment and the energy that goes into it. So what we found is that by allowing to start this conversation and tell them exactly how much we could potentially save them, they were usually ignorant to that before and quite excited and enthusiastic to adopt our services.
Okay, so you're saying they didn't do it back then. There's still some opportunity.
Yes, especially in the more rural, our market area.
And that 370 million that you mentioned in annual revenue opportunity, was that assuming, is that the total addressable market, assuming 100% penetration and no
Yes, that's our TAM in the 7,700 wastewater treatment plants that use variable frequency drive motor controls. There's opportunities to scale up to larger cities, but we think that to broaden our total addressable market is going international. There's places international that use similar treatment processes. So expanding our technology internationally would be a way to grow that size.
And one other question, you mentioned a 90 million exit value. I think it was in year 6 or 7. To whom? What types of companies or partners would this be most strategic for?
Yes, so we listed Siemens as a competitor, but they're also a potential acquirer. There's also several service companies in the wastewater industry, as well as continuous emissions monitoring systems. So there's a handful, but we predict a company like Siemens or E&H, a large wastewater company that focuses primarily on service in the wastewater industry. And our EBITDA multiple was 6.5 on that exit. That's how we got to 90.
Time is up.
All right, thank you, Contraire. Please shut off your videos, and judges, you have 2 more minutes to score.
Thank you, everybody.
All right, up next we have Harmony Water. So Harmony, please turn on your video and start your screen share.
Hi, my name is Grace Connors, and I'm introducing Harmony Water. Harmony Water is enabling more water production for less energy. Seawater desalination is growing rapidly to meet the global demand for drinking water. The global capacity of seawater desalination is going to increase by 20 million cubic meters per day in the next 4 years. This represents a $30 billion investment in seawater desalination plants. Overwhelmingly, the most popular technology is reverse osmosis, or RO. Reverse osmosis is a membrane-based technology that requires a high pressure for operation. But because of that high pressure, there's a high energy consumption and large carbon footprint associated with the technology. If we take a state-of-the-art plant located in Carlsbad, California, it produces 200,000 cubic meters of fresh water per day. It has an electricity cost of 750 megawatt hours and 250 tons of CO2 emitted. And while 200,000 cubic meters might sound like a lot of water, it's actually only a fraction of the water demanded by the residents of San Diego. That's where Harmony Water comes in. Harmony Water provides the most efficient RO process, increasing current efficiency by 6%. And while 6% might not seem like a big number, if we look at the process efficiency history of RO, we'll see why this is so significant. When RO was introduced 50 years ago, it had a process efficiency around 7%. The major technological breakthrough of the energy recovery device and improved manufacturing practices brought this up to around 50%. But in the last 10 years, we've hit a wall. We haven't been able to improve the process efficiency nearly at all until Harmony Water. Harmony Water is the next big step towards the maximum practical limit of RO process efficiency, which is theorized by industry experts to be around 70%. In order to understand how Harmony Water is able to do this, we need to understand a little bit more about how conventional RO works. For conventional RO, the osmotic pressure of the fluid is increasing through the distance of the system as more and more fresh water is produced. Therefore, the incoming fluid needs to be pressurized beyond the osmotic pressure at the very end of the system to produce fresh water. This creates all this wasted energy because everywhere else in the system is overpressurized. In our patented batch RO system, the water salinity is changing within the system over time instead of distance. This allows us to apply just enough pressure to overcome the osmotic pressure of water at every time instant, thus recapturing all that previously wasted energy. The savings compared to conventional RO are immense. If we go back to our Carlsbad example, we could save them $2 million in operating costs, 30 gigawatt hours of electricity, and 9,000 tons of CO2 each year. We've already proven this concept at the bench scale and formed key industry relationships. Our next step is to interview 100 additional customers, develop a large-scale prototype, and install a commercial pilot at a customer site. While this might seem like a long product development process, water treatment is a referrals-based industry, so it's important for us to have a successful installation under our belt before we start generating a sales pipeline. It's also worth noting we're currently in conversations with Suez, Torrey, and Singapore's Public Utility Board, who have all expressed interest in piloting our system with us. Once we've proven this concept at scale, we plan to provide water as a service to Caribbean islands. The Caribbean is a great first market for us because energy costs are some of the highest in the world, and there's already a demand for desalinated water. We plan to build and operate plants and sell water to our customers. This gives us recurring revenue, and our customers can avoid the hassle of operating a desalination plant. Seven Seas Water has already proven this business model is successful. With that recurring revenue, we'll be able to reinvest in more plants. And as we continue to grow, we'll reach profitability within 5 to 6 years. We will require an additional $2 million as an initial investment to start building and operating those plants. Between Quantum, Sahil, and myself, we have a lot of experience working with desalination technologies. Quantum has developed batch RO for his PhD thesis. Sahil has developed other desalination solutions, which are now being commercialized in India. And I previously scaled and commercialized desalination equipment at a startup I used to work at. Together, we're going to be able to move batch RO out of the lab and into the real world. Harmony Water, we're producing more water for less energy. Thank you.
Thank you, Harmony Water. Judges, please turn on your cameras. All right, your 10 minutes starts now.
So what exactly is different about the hardware here? Like, could you just run an existing RO facility on a batch mode?
Hi, Ariel. Sorry, having issues. There we go. Yeah, so we actually have a patent on the process, and there's a bladder that is key to the process that allows you to change the system salinity and thus the pressure over time. So there is a bit of hardware involved and a patented process, which MIT has been granted a patent to protect that process. But it uses all the same regular RO membranes, the same ones that are used in a conventional RO system.
So can you, following up on Ariel, could you retrofit an existing system just by adding that bladder?
Yep, yeah, in theory we could retrofit a system and insert a bladder into existing pressure vessels. In practice though, we don't think a lot of desalination plants are going to want to shut down because the plant downtime is rather expensive. So in our financial projections, we are relying on new installs, but if someone wanted to do it, we could definitely do a retrofit.
Yeah, and one follow-up on that in terms of your financial projections. So you're showing I think a break even after 6 years and 11 plants with sort of an initial capital outlay of $2 million. So that's going to do it. Plus just that recurring revenue you get in from sales is going to get you to those 11 plants.
Hello. Yeah, that's exactly right. Because of the energy savings that we enable, especially in the Caribbean market where the cost of energy is very high, we're able to, based on the energy savings, able to use the recovering revenue, reinvest and scale up to those plants.
And I would add that in our financial model, we assumed one plant size. So depending on the plant size, it might be more or less plants if we're making larger plants or smaller plants. And these are modular units So you can just add a couple more if you wanted to do more throughput of water.
I'm wondering from an environmental impact, or maybe I'm wrong on this, but desals, they have such an impact on the ocean itself and warming the ocean and all that. So your technology, does it allow more desal to happen and come online, and therefore more warming of the ocean, and therefore your environmental impact is it really what's needed right now? So it's more of a philosophical question, I think.
Yeah, well, so just focusing on the market that we're looking at right now, the Caribbean, even without our technology, about 60 new plants are going online because this is the way that they're producing fresh water. So the goal here is to reduce the energy consumption of those plants that are already going online.
So Grace, I think I heard you say that this business model is already proved to be successful. And could you elaborate on that? Was that somebody else who's done this, or could you?
Yeah, yeah. So, so Seven Seas Water is a company that operates desalination plants, and they have some in Latin America, some in Africa, and some in the Caribbean. And they are relying on this water as a service model where they build, own, and operate their plants and sell the water directly to, in their case, municipalities. And they've been really successful. They IPO'd a few years back, and it's proven to be a really profitable method for desalination. And so we're looking to implement a similar model, but we think we can do it at lower cost because we can save energy in comparison.
Got it. Thank you.
So I'll jump back in. So you said this is modular, so I'm assuming this is like skid based. You know, I think we've got Matt from Cambrian coming on later. And I know they sort of do something similar to this. So the other question is, what's your target? So you say the Caribbean, have you already started relations there? Do you know where you're going? You know, what's your beachhead, literally and figuratively, in the Caribbean?
Yeah, so the first goal, as we showed in our milestones, is to really prove this at a pilot scale. Now, in order to do this, we've identified that Singapore Public Utility Board is the ideal partner. They are the premier municipality for desalination, and they already have innovation programs in order to test out this type of new technology. They've invited us to pilot, and so we do think this is the best path forward to prove the technology at a larger scale before moving on to the market that we're interested in.
Any other questions from our judges?
Also, I'll just say I worked at Cambrian for a little bit, so Matt, hopefully Dr. Matthew Silver will be okay with it.
I guess just one last question is kind of, are there any other things that you expect to have to re-engineer or that would present technical risk for you associated with running this as a batch process?
So most of the parts are off the shelf, so standard RO components. The bladder is the one piece that we would kind of have to re-engineer ourselves. Speaking to technical risks, though, one thing that we are planning to look at and investigate over the next year or so is the impact of variable pump efficiency on the energy savings that a batch process could achieve. So that's something that we're looking at and probably our biggest technical risk right now.
And one last one. So I know you're focused on the desal, but just from a technology perspective, you know, could this, you know, you're dealing with brackish water in that space. Can this go oil and gas? Can you do fracking or no?
Yeah, so we looked at several markets when we started this process. The problem is that in some of these other industries, water desalination is just a small component of a larger process, and so savings there are not as meaningful when you're looking at the larger process, which is why we're targeting specifically seawater desalination, where the energy cost is a significant portion of the cost of water production.
Thank you.
All right, if there are no other questions, thank you, Harmony Water. Please turn off your videos and we will go on a break for the judges to enter their scores. All right, up next we have Nitricity. If you could turn on your videos and start your screen share.
Good afternoon, everyone, and we are Nitricity. Our company believes in carbon-free nitrogen fertilizer.
There are problems today with the production, distribution, and application of nitrogen fertilizer. In the production, it comes from the Haber-Bosch process, which is a centralized and extremely capital-intensive process. There comes the video. There we go. In the distribution, farmers end up paying about 3 to 5 times the gate cost as they would pay if they were at the Haber-Bosch facility. And in the application, there are additional inefficiencies which lead to soil greenhouse gas emissions and a loss of the nitrogen product. All in all, we see about a 2.88 gigaton opportunity of mitigating the CO2. Nitricity's vision is to fix nitrogen where it is needed, using no carbon, no supply chain, and empowering the application of the end user. You can see a couple of versions of our product attached to a drip irrigation plot on the left, and on the right, a larger scale centralized pivot system where we attach in the middle, and it's about a 130-acre system, quite a bit bigger. And then we use renewable electricity, air, and water to make our nitrogen fertilizer and effectively enable the farm to fertilize itself. Our innovation is to fix the nitrogen using a plasma-based process. We take these renewable resources and make nitric acid. That nitric acid is made in an ultra-low CapEx process with no fossil fuels, no high pressure, unlike the incumbent process, and enabling small-scale feasibility. Then we can match the fertilizer type with the need of the end user. We can use direct nitric acid in California farms where there's actually alkaline soils and farms are applying acid and fertilizer on their farms. And we actually can give them 2 products for the price of 1. We can also neutralize our product very easily to form calcium, sodium, potassium, or phosphorus-based compounds, or we can convert it to ammonium nitrate with IP that we have at Stanford, and basically all to match the fertilizer type that the end user wants.
This dynamic innovation has access to an immense and truly varied global marketplace. This can be represented by the following figure, which shows on the y-axis the total market size in billions, as an approximate function of the cost of fertilizer, shown in dollars per pound of nitrogen on the x-axis. The lowest cost and most competitive nitrogen in the market is seen in marketplaces like the American Midwest, where in an Iowa cornfield, nitrogen will cost about 20 cents per pound of that. On the other end of the cost spectrum, the $3.2 billion lawn and garden fertilizer marketplace is something that a homeowner would see at Home Depot, where fertilizer costs $20 per pound of nitrogen. Nitricity, with our MVP, is already producing fertilizer targeting commercial scale application, somewhere between organic fertilizer and bulk fertilizers from Haber-Bosch factories. This includes a margin. However, the main kicker is that this is with an MVP that was rapidly prototyped using McMaster-Carr and Amazon.com parts. We've been very capital efficient and built a miniaturized chemical process underneath a set of solar panels for less than $170,000. And I'd like to emphasize how real this market opportunity is. And we've begun the commercialization process in California. There are customers that have hair on fire soil pH and nitrogen pain points right now where our technology makes cost sense for them. Our nitrogen production asset, actually our first one, is shown on the bottom right of this slide. We own and operate, and we charge the farm a fertilizer subscription, which comes in the form of $ per acre per year. Nitricity's vision is to drive deeper decarbonization and innovate and push left on this market curve. Our first checkpoint in doing so is to improve our energy efficiency, but most importantly, we seek to transition from a prototype that was put together with Amazon.com parts to a product that leverages a global supply chain to drive down the cost. To support this transition, we're raising $500,000 today as Safe Notes grants, and this is what the MIT Clean Energy Prize, if awarded, would be used to support. We have an amazing team spinning out of Stanford University right now. Jay Schwalbe, Dr. Joshua McEnany, and myself, Nicholas Pinkowski, have been working on this for years, and this is our first production asset we put on the roof of a building. Over the past year, we've had many business competition awards and grants from Stanford University, Caltech, StartX, and we were recently voted by farmers the best pitch at the World Ag Expo in California. We're delighted to work with a substantial customer interest right now from farms big and small around the world. And it's my pleasure to let you know that we're operating actually on a $60,000 fertilizer contract right now in Fresno, California, to provide the nitrogen for subsurface irrigated processing tomatoes. And so there's actually a picture of our system here, and we called it the Bosch squasher. And this system is effectively mitigating 0.5 ton of carbon dioxide equivalent emissions this year. And I have the data pulled up on a screen to my left here. It's posting to the cloud right now. It's been on for many hours today making fertilizer, essentially 150 miles away from where Josh and I are
15 seconds remaining.
Thank you. In summation, the way nitrogen fertilizer has been done in the past 100 years is poisoning the same environment that farmers and entrepreneurs are seeking to cultivate. It's our company's mission to shift the focus from the factories into the fields, where this can, and in doing so, decarbonize the manufacture, the distribution, and the application of nitrogen fertilizer. This prize would be extremely impactful for our company. We're very grateful to be in these finals, and it would have an immediate climate and company impact. Thank you very much.
Thank you.
Thank you, Nitricity. You can turn off your screen share, and judges, please turn on your video. All right, 10 minutes starts now.
One question I have is just how capital intensive is it to scale to meet customer demand? What type of capital would be required for that, and what proof points or what gives you confidence that that capital will be accessible when it's time?
Thank you for your question. To provide a bit of context, I can contextualize it within the scope of our current fertilizer contract in Fresno. So we expect a system that would be able to fertilize 1 acre, and effectively it is 2 55-gallon drums. We fit all the system in 2 drums that sits underneath an array of solar panels. And so the bulk of the system cost is actually the solar panels for this. Our system is very low cost, and as we scale to larger arrays and larger acreage, our system scales very well with size. And so it is, you know, when Josh described it as ultra low CapEx, the process we're using right now is very low CapEx to do this, and it'll scale well with size. You know, getting low cost of solar panels is the crux of the problem. And we're going to start out by leveraging actually PPAs to defer that cost to another player.
Thank you.
Are you envisioning the systems to actually be grid connected at all, or is this a totally off-grid system that's just producing the physical product?
Our first products are off-grid. So I've designed everything to be able to run directly off of the solar panels, which is a nice modular way to operate. But we're actually applying to a grant now where we're trying to figure out ways to use intermittent and cheap electricity. So we definitely are trying to take advantage of the opportunity to be able to connect to the grid as well. But yeah, I would say initial beachhead markets and the way we've designed the system so far is for off-grid.
Cool. And then can you speak a little bit to what your purity requirements are on the water, and to what extent the availability of appropriate water streams is a concern, and what you expect the ongoing maintenance requirements to be for the systems?
Thank you for the question on water. I can start with that and then talk about maintenance. So currently in the farm in Fresno, the water that would otherwise go to the field, the irrigation water that would go to the field, we reroute some of that and have it go into our system. And the amount of water that we require in relation to the amount that's actually needed to grow the crops is very, very, very small. We need very little water. The purity requirements, we are working just fine with the irrigation water right now. When it comes to maintenance, you know, for our first system, we actually rented a place in Fresno, California, and we have someone always there. And this is like the first time anyone has ever distributed the production of fertilizer in the way that we have now. And so this proof of concept, you know, we're taking data from, but it's been running for many days straight without anyone having to test it. And we plan on having it run the whole 150-day season. In the long term, we expect someone to have to come by once a year and check in on the systems, and we're factoring that into our cost estimates.
You're not seeing any scaling on that? Sorry, just to close the loop.
To clarify, you asked scaling on the maintenance costs. Is that right?
No, I mean like physical scaling on the on the system itself.
Gotcha. And the costs associated with that?
Performance degradation associated with that.
Gotcha. And so as we scale, we actually can leverage less components. And so it's going to be one pump for a larger system. And so it's going to be the lifetime of the expected pump. We hope to be able to go up as it gets bigger, as it'll be approached more commercially applied pumps.
Sorry, I mean like mineral scaling.
Got it. I'm not sure if I totally understand.
Scaling, like coding, not scaling, growing, scaling,
right.
Coding, scaling, different scaling.
Like, are you seeing any mineral buildup on the system from the fact that they're using water with salts in it?
Ah, gotcha. We totally understand. Yeah, we think there might be a little bit of copper in the irrigation water, actually. And so it's been running for a very long time, and we haven't had too much performance degradation. But we have made several comments in the field. It's like there might be a little copper or something in this water, and we do see traces of that buildup in one part of the system. But so far, it hasn't been a big problem. But I imagine that might be the importance of swinging by once a year to replace a single component or so.
Yeah, been pretty happy with the maintenance requirements on the system so far, but any of that buildup would basically be replacing small components that don't cost a lot of money.
Can you go into a little more detail on your sales strategy? I think you said their beachhead market is farmers. Are they large scale farms, industrial? What type of farms is that? And then are you not going to be a consumer play at all? You don't see you going into the consumer sector anytime in the future?
Our company's mission and vision is centered around decarbonizing the nitrogen fertilizer industry. We've identified, and we've actually gotten requests for folks at StartX who said, can I buy your fertilizer for $20 a pound right now? I have a tomato plant. And we'll probably supply some of that. It'll drive some good revenue. But our main focus, and we will stay focused, is on commercially applied fertilizer. That's how you can have a gigaton per year carbon dioxide impact. And so that's our main focus on that end.
The big goal with that so far has been working on with big companies like Valmont Industries is a giant irrigation company that provides these center pivots. They've given us a letter of support, as well as Wonderful Pistachios, who has a pH need right now. So they would like to use the nitric acid directly, which is a great opportunity for our beachhead market.
And our sales strategy with those customers, to finalize your question, is we ask them, we find customers in zones that we anticipate, have a hair on fire, nitrogen or acid problem, soil pH problem right now. And we just ask them about their nutrients and ask them what they like and what would be the ideal form. And then we talk with them and try to cater a solution to their needs.
So one follow-up to that question. So I think you're saying you're not going to sell fertilizer, but would you sell your system? Sounds like you got to have a subscription revenue-based model where you're doing sort of, I guess, fertilizer as a service, where you put it there and it does it. But what if I'm a farmer? It sounds like you're not doing that much maintenance. Can I just buy it, as a product?
Yes, sir. And actually, we've gotten requests for folks who just want to buy an acre system and said, I'm interested. Can I get a quote for an acre system? And absolutely, that helps us get on our feet as a company. In the long term, say for a 30-acre farm, we want to make it as easy as possible for that farm to adopt this product. And currently, their current fertilizer bill for the year comes at the worst time. It comes, exactly when cash is needed the most and before they're going to get revenue for a long time. And so for these larger farms, aside from who don't want to purchase a whole system or make a capital expense right now, we're going to offer a subscription model, and we think that would be appropriate. And we're going to time the financing of that such that it reduces this financing pain on the farmer.
Given that maintenance is light, is there anything else they get on that subscription beyond the financing benefits?
Yes, sir, and we give them control. That's our big selling point. Is say, sir, ma'am, how would you like total control over your nitrogen supply You'll have predictable costs. You can apply it more frequently. Your field will effectively fertilize itself. And you'll be able to analyze the profile, and you'll be able to control this from your desk, and you won't have to send anyone out there to inject it or turn it on. And so that's part of the value add that we're adding to our very first farm, actually, is it, it's connected online, and the farm manager can select when he wants to inject fertilizer and how much and at what profile and at what pH.
And he could not do that if he owned the system himself?
If he owned the system himself, we're still gonna provide that option, that interface option, to make it as easy as possible.
And I would add to that, a lot of farmers apply fertilizers in bulk today because that's when it's cheapest. But if they had more control over their fertilizer supply, such as we provide with this system, then they could increase their nitrogen utilization efficiencies by applying more frequently. So that's one of the benefits that's offered.
1 minute remaining.
Any other questions from our judges? All right, then with that, thank you, Nitricity. You can turn off your videos. Judges, please take 2 minutes to fill out your scoring forms, and then we'll ask you to leave the webinar to join the separate Zoom so that we can deliberate. For the rest of you, we have a special treat. We'll have 2 of our alumni companies come on to do a fireside chat. You'll be able to ask some questions throughout that session. That will be moderated by Wynn Tucker, who is the other co-MD. So give us a few minutes. We'll have a brief intermission, and then Wynn will come on to have the Zoom side chat. Thank you, everyone.
All right. Well, hi, everyone. My name is Wynn. I am, along with Monica, a managing director of the Clean Energy Prize this year. Monica is over in a private Zoom with the judges who are now in their deliberation phase of the event. And we are really excited to bring in 2 of our alumni. First will be Elise and then Matt after that, to each talk about their startup journeys. And as some of you dialing in might know, the Clean Energy Prize was actually the first university clean tech startup competition in the country, now in its 13th year. Over 100 companies have launched out of the Clean Energy Prize and have raised over $1.2 billion in funding. So we see it as a really critical stepping stone for so many early stage clean tech companies. So first up will be Elise Strobach. And Elise, let's see if we can get your video on. Elise is the co-founder and CEO of AeroShield and was the winner of last year's Clean Energy Prize at MIT. There we go. Elise's founding of AeroShield was based on her doctoral work in mechanical engineering at MIT, and now her mission as CEO of AeroShield is to provide the next generation of energy efficient and cost-effective materials for building windows, bringing us one step closer to a low carbon future. So for all the audience tuning in, there's a Q&A feature you'll see at the bottom of your screen. So I'm going to start off asking Elise a few questions about her journey and her process. But feel free to submit some questions. I will keep an eye on those, and time permitting, would love to ask Elise some of them. But first of all, Elise, welcome, and if you just want to tell us about what AeroShield is, and last year you won the Clean Energy Prize. What have you been up to since then?
Yeah. Thank you for that great introduction. Very excited to be a part of this year's event, and so happy that it's been going on. So a little bit of background on AeroShield. So, this has been based on as Wynn gave this excellent introduction, it's been based on my graduate research looking into porous glass insulation. And in particular, we found this application space in windows. And the time of the Clean Energy Prize last year was really this transition of taking this fundamental work and looking at, really investigating how do you actually have an impact when you have a breakthrough, and all the pieces that come with looking at actually commercializing a technology. And the Clean Energy Prize for us provided, mentorship, opportunity to connect with this ecosystem. And it also kind of took us through the paces. The judges' questions, they were fantastic. They kind of triggered us to look at things in a new way. And definitely in addition to being a finalist and being a winner, really gave us a lot of momentum. So I would say that for us, the Clean Energy Prize was this like very pivotal experience that kind of kicked off what really ended up becoming AeroShield, the company. And so actually within the past few months, I have defended my PhD and been able to transition into AeroShield full time. So that's where things are now.
Awesome. And I know that in the past year, you've been on a winning streak as well, winning the Clean Tech Open. And talk to us a bit about how the company itself is developing and kind of what your current priorities are right now.
Yeah. So we definitely, kind of after the Clean Energy Prize, that timing, we realized, we were on the track of something, but there are a lot of pieces that come with. I mean, it's really easy especially with a research background, to say, we have a great idea. Oh, it's as easy as plugging it in. But I think, as you can see from the presentations of the companies today, that there's a lot of pieces that have to come together. So, after the Clean Energy Prize, we went out and we found more opportunities where we could get trained in this way of thinking about commercialization. And so definitely the Clean Tech Open, we engaged a lot with Mass CEC, actually had some funding come in from them, which really helped support, finish those last questions remaining on the real fundamental core principles of the technology. Not only is this an interesting technology, a good breakthrough, but is it actually commercializable? So in the past year, we've set up a lot of framework. I had the great opportunity to bring on a co-founder, a colleague from MIT, Kyle Wilkie, who's jumped in. And so we've actually been able to, two people tackle this challenge and, really set together the foundations, incorporated, been a part of a lot of great programs, and really made a lot of progress. And we've actually just started before kind of the business shutdowns kind of changed a little bit of our planning right now, but we are actually beginning to produce commercial grade process equipment. So a very exciting time.
That's amazing. And we've had a question come in asking you to just talk a little bit more about the mechanics of the technology of AeroShield. So you don't have to defend your, your work again, but just give us a little more detail on that would be, I think, of interest to the audience.
Yeah, certainly. So the core technology is based on something called silica aerogel. And aerogels are just super porous materials with pores that are typically less than 50 nanometers in diameter. So we're talking really small features. And so when you make this aerogel material out of a glass base, what you can end up with is basically a super porous glass that we manufacture in a sheet that almost has a texture of styrofoam. So it's 95% air. And we've engineered these pores that trap this air, that give it this super insulating properties. We've engineered those to be so tiny that they're actually very, very small, smaller than wavelengths of light. And so I actually have a sample over here. Actually, when we put it between two panes of glass, it looks clear. So now you have something that's incredibly insulating, more insulating than gas. And when you put it inside of a window, you get all of that great advantage of the thermal efficiency, making our homes more energy efficient and more comfortable.
Terrific. And another question's come in. I love the audience questions just about the challenges of moving from lab to commercialization. What have the kind of big speed bumps been? How have you been getting through those sort of commercialization challenges?
Yeah, it's a great question. There are a lot of barriers, and I guess one caveat I'll say is that it's definitely very dependent on the technology that you're looking at. And especially, about the personal kind of vision you have for a technology. Somebody else who's working at the same material might have developed it differently. And so that path is so variable, so open. I would say that for us, one of the biggest challenges has been, convincing other people of the technology has been surprisingly easy, because we see those weak points, we know what they are, and we focus our time a lot on plans to make them, to overcome those or to prove those out. But another aspect that you can't forget is not only the market side and saying, will I have a customer once I make this, but all the logistics of delivering a solution to a customer. So for us, the ecosystem is everybody's startup ecosystem is unique, but for us, that's still very true. There are a lot of players with a lot of nuanced relationships, and convincing potential customers, investors, and potential users of the product, homeowners, that the technology not only will work, but that AeroShield is the best one to deliver that solution. There's a lot of little pieces that they add up. And so there's been a lot of learning experience, but I would say that, the MIT ecosystem and events like the Clean Energy Prize and the Boston ecosystem in particular has done a fantastic job of helping support us and get us through learning all those little quirks.
Yeah, and speaking of kind of the journey that you've been on, and we have teams that have already pitched today. I'm sure we have other founders or prospective founders dialed in, students on the call. So for thinking back to yourself a year ago in this competition, or even before that, if you want any kind of advice or learnings that you've had in the past year that you would like to share with those early stage founders.
Yeah, definitely. I think, my bias is definitely going to be from the research perspective, which, stereotypically we like to get down to the basement and just kind of work there and work in our little box and get into the technology. And that's really exciting. It can be really motivating and invigorating. But at the end of the day, I think the biggest lesson that I've learned in the past year has been, people are your number one resource, whether it's the ecosystem, the amazing funding opportunities, and, entities that are supporting events like this, to the questions that we're getting today. I mean, even things that seem simple from an outside perspective challenge us to rethink what we thought we knew. And it can be as simple as somebody tossing out, oh, have you considered just growing your material on glass? And we might go, oh no, that's ridiculous, you can't do that. And then you think about it and you go, well, fundamentally, why not? And then you go through the path of looking, maybe this is a better solution. And I would say that, the network that's available, particularly in the clean tech space, is just fantastic. And I would recommend to anybody looking at startups, go out, tap into the resources that are available. There are so many people that are so caring, so supportive of not only your mission, what you're doing, your technology, really geeking out with you about it, but also you as a person. We all in this ecosystem are looking to make the world a better place, and take advantage of that. Really use that as your most valuable resource.
And thank you for being one of those people and joining our presentation today. I actually can report from our Q&A that Todd Hines is interested in purchasing some demo units, so I can make that introduction, I'm sure, which was needed offline. So last question is just what's next for AeroShield?
Yeah, so what's next for AeroShield is we're looking at actually, operating on this vision, really executing. We've spent a lot of time putting together these resources of building out our team and getting into environments like just starting out in Greentown Labs Incubator, like really working in that community and getting all those resources pulled together. And now it's really come time for us to execute. We have a strong development plan. We have, our team is growing at a good pace. And I think it's just about, executing on those milestones that we've spent, a year really outlining and developing.
Awesome. Well, we're really excited and supportive of your journey up ahead. Thank you so much for coming in and bringing in your experience. And we, really appreciate your joining us today. So good luck. And we're now going to move on to the next alumni spotlight, which is going to be with Matthew Silver. So let's see if we can coordinate the video with that. Hello, Matt.
How are you?
We're great. We're great. So, so Matthew Silver is the CEO and founder of Cambrian Innovation. He spent nearly 20 years working to close the industrial resource loop, innovating toward a truly circular economy. Cambrian is a disruptor in wastewater management and is working to convert industry to ecosystem. So Matt is also a graduate of MIT, where he received a PhD in engineering systems and a dual master's in aerospace engineering and technology and policy. So, and he competed in the Clean Energy Prize back in 2009. So we are delighted to welcome him back today. And Matt, if you want to start off just telling us about Cambrian Innovation and the past, 11 years.
Yeah, it's flown by. Thanks for that. And thanks for having me. I really appreciate it, Wynn. It's good to be able to talk to everybody and some folks I know in the audience. So hi to everyone. What Cambrian does, at a high level is we help, we're in the industrial wastewater market, basically. We help companies specifically take polluted water and convert it into clean water and clean energy. And we're doing that with a proprietary product suite. So the product we originally got onto the market, plus a couple of others that we've developed or acquired. And we're doing it as a service. And what we mean by as a service is similar to a power purchase agreement in the solar industry. We're looking to drive what we call a water energy purchase agreement in the water industry. And we think there's a big opportunity to make a similar shift. And we're kind of working on that. And so that's what we do in terms of our stage. You mentioned we've been around for a little bit, and I'm happy to get into the phases that we've gone through and the lessons and the learnings that we've had. But at this stage, we've got a little over 30 people in the company. We've got an office here in Watertown. We're actually deemed an essential service in some ways. So we have aspects of the folks still operating. We've got an office in Dallas through an acquisition we did at the end of last year, and a small office in San Francisco. We've got in total 22 plants that are operating primarily in the food and beverage industry, but also in sort of resorts. We've treated over actually 1 billion gallons of water at this point and generated or saved over 1 gigawatt hour of energy. So we're excited about kind of the phase that we're in and where we're going from here. Work with a lot of great companies in the market. And I think I'll leave it there. I think you had a question about kind of how we got here over the last since we started?
Yeah, lots of questions, and I'll also remind the audience if you'd like to submit questions for me to ask, depending on time, we hopefully will get some of those in. But yeah, Matt, maybe you mentioned different phases and different lessons from each, and I think one theme we've seen today in our pitches is actually companies starting with a product focus and then potentially looking down the road, moving to a service model, or maybe even starting as a service model in some cases. But can you talk through that, the progression for Cambrian?
Yeah, I'd be happy to. And I come from a technology background, as you mentioned. I have a PhD in engineering, and I was in aerospace before that. Our company has gone through a couple of phases, kind of as a starting with where it did. Originally, it was actually kind of applied R&D. We got a lot of grants. And develop sort of the initial technology or range of products. And we're really just interested in the technology, to be honest, me and the co-founder, and the different places it could go. We then had a phase of sort of early commercialization. So when we won the Clean Tech Open, and I think we were in the finals or runner-up in the Clean Energy Prize, that was in early 2000 and late 2009, early 2010. We were developing one product at that point, which we call EcoVolt. That was our sort of first bioreactor. We thought of it as a minimal viable product. And we commercialized that by scaling it through time from like a liter scale to like a 50-gallon scale to larger than that, to demonstrations. And that took a couple of years to really figure that out and move it forward. The next phase from there was basically demonstrating that it would work in the market. So once we showed that the product could work, we sold it and had sort of our early demonstration plants. And that took a couple of years as well to kind of hone those in, and a ton of lessons learned on that of what to do and what not to do when you're getting your first product out into the market, particularly if it's industrial scale. And then from there, I think we went into more of the company growth and optimization phase. So started thinking about, we know we have a product, we know it works, we know the margins aren't high enough, and we probably haven't optimized our sales process. And that's when we started to shift towards this. And the margins not being high enough is normal for an industrial product like that you're first getting and just proving it works. And so we went to optimize that. We cut a lot of costs out of the product, started professionalized delivery, and shifted towards this service model that we now see as sort of the biggest opportunity. Really is the business model that we've developed around the product, and that's led to kind of an acquisition phase with what we did at the end of last year, an acquisition of a company based in Texas.
Yeah, that's really interesting background. We've had an audience question, I think, kind of clarifying Cambrian's business model and asking, is this service intended to replace already installed water treatment mechanisms, or is it additionally installed for performance upgrades?
Yeah, all of the above. The primary driver for people that purchase our product are, let me put it this way. We're selling into food and beverage and resorts and private domestic right now. There's about 22,000 plants in North America that fit our, that produce enough water where they would need to be, they could use a system like ours. And the use case will vary. So some folks have a plant and they're growing and they need something new, and we can make what they're doing much more efficient. Some folks don't have anything, and we're going to sell something to them for the first time. And other folks, it's you know, any range of reasons. They've got something, but they're paying way too much. They're not necessarily growing, but we can just cut their costs significantly. So it's kind of a range.
Yeah, thanks for that clarification. And so to go back to like the early stage, you know, your early years, which sounds like was in the late, around 2008, 2009, 2010, and thinking now, obviously with sort of economic uncertainty and crisis and challenges facing so many aspiring founders and, you know, the teams participating in our competition, other prospective founders. I know you were at a different company phase then, it sounds like more R&D, but it was a sort of parallel in the sense of having these economic headwinds at that time. So was there any kind of lessons or learnings or advice you'd have, given your experience, you know, launching a company at that time, that you think would be material for someone at this stage to have in mind?
Yeah, I think, well, first of all, there's a lot of federal money out there in 2008 with the stimulus package that was done. So I don't, you know, it's a different administration now. I don't know if that's going to be exactly the same thing, but we definitely benefited from that. We got a number of grants to explore what we were doing from a range of agencies. We applied for these SBIR grants. Because we were focused on the technology at first, we probably, it's probably both a positive and a negative, but we took a little bit more time just honing in on the technology. We had seen a number of companies kind of maybe get ahead of their skis a little bit and starting to sell something that wasn't fully baked. And myself and the co-founder wanted to be careful around that. And I think that ended up working to our benefit. It did take a little more time because we wanted to perfect things, but it works to the benefit in terms of the company. So we were very bootstrappy in the beginning. And that is something you need to do early on as you get a company off the ground. But it's a great time to start a company, even in a downturn, even in a situation like this, because the good investors know that this is a great time to invest, because there's going to be an up track at one point, and it's great to have your product and your company figured out at that point, right? So I'd encourage folks to do it.
Great. And one thing Elise was actually just talking about that I'd love to run by you is just sort of the support that she got from within the Boston clean tech ecosystem and the different partners that were helpful along the way. So what, just interested in terms of the Boston clean tech ecosystem, how did you find support and help in helping launch Cambrian Innovation?
Yeah, the biggest thing I would say is the coworkers and the friends and the people that are out there trying to work on similar problems, and the fact that that's built up to a kind of critical masses is so valuable. And you know, just the conversations with friends that are starting similar companies or trying to start companies and thinking about that. I mean, it's so valuable. We benefited from, there was like this first wave of clean tech that kind of went and then came and went, and we were able to, there's a lot of lessons learned from that, particularly on financing and capital structure that we try to take into account talking to people. So that's the biggest thing. We have investors in the Boston area that we're very grateful for, and that's important. And you know, it's the people at the end of the day. That's what an ecosystem is, right? So it's everything that comes with that.
Awesome. And last question for you is just what's next for Cambrian Innovation?
Yeah, well, we're pretty excited about where we are in the market right now. We've really broken through. I'd like to say we've, quote unquote, crossed that chasm in terms of, number of plants out there operating, proven, working with a lot of the best companies in food and beverage, working with InBev, Louis Vuitton, Moet Hennessy, Sapporo, Keurig, Dr. Pepper, some luxury brands in the resort market. So we're starting to drive from the hunting mode of trying to pick out the plants to the moving on to corporate partnerships and driving this WIPA model in the water space. And so it's all about sales and optimizing that. And that's what we're doing.
Terrific. Well, thank you so much for joining us. It's been really interesting, I think, for our audience to learn about Cambrian, to get some insights on how the company was launched and grew. So we really, really appreciate you joining us.
I really, really appreciate your having me. Thank you so much, and good luck to everybody in the competition.
Thank you. Terrific. So with that, we are now, I've gotten word that the judging deliberation has concluded, and we are ready to move on to the final portion of our event. And so we're moving on to the section of announcing prize winners. Before I announce the awards, there's a few important thank yous to make. There's actually so many thank yous that we could make. I'm going to try to limit myself. But first of all, I'd want to thank again our sponsors, the Massachusetts Clean Energy Center, Morrison Foerster, Novartis, the Wells Fargo Innovation Incubator, and then the MIT Energy Initiative, as well as our partnership with My Climate Journey and featuring the winner this year. These sponsors have been critical in helping us achieve the virtual version of the Clean Energy Prize. Financially, they've been on the phone with us. They've been real collaborators in helping us pull this off. So this would not have happened without our sponsors, and we can't express enough of our appreciation for them. We'd like to thank all of the teams in our competition for your resiliency, adapting to this virtual format, your enthusiasm for commercializing your clean technologies, and your amazing pitches and development throughout this competition. We work with so many professional experts and volunteers who serve as mentors, who serve as judges, and have devoted their time and expertise to moving this competition forward, especially in these challenging times. So we are very appreciative for all of our mentors and judges and other volunteers with the Clean Energy Prize. And also to all of you on the webinar who are tuning in today. So as I think we've heard a few times today, the importance of developing, scaling these climate, water, energy solutions, it's never been more important, and these startups need our support now more than ever. So if you would like to get involved, we have a number of ways to get involved, including as a sponsor. You can make individual donations, you can volunteer as a mentor, you can join our network in a number of ways. Please visit our website at cep.mit.edu. You can email us at cleanenergyprize@mit.edu, and we'll post those both at the end of this award ceremony. And also, if you'd like to connect with any of the teams in this competition, same thing, email us. We're happy to make those introductions. The MIT ecosystem has been incredibly helpful. Our advisors, Todd Hines and Bill Aulette, and in planning this webinar, we've received help from so many different sources: the MIT Energy Conference Leadership Team, the Water Innovation Prize, 100K team. More people than I can mention have pitched in to brainstorm how to make this virtual competition successful, and we're so appreciative for your support. And we're very delighted to be a part of the broader Boston ecosystem, and I think a number of the organizations that have been mentioned already, Greentown Labs, Clean Tech Open, and many, many more are just incredible partners as we have run this competition this year. So we're getting closer to the announcement. I would like to ask all of the members of the Clean Energy Prize leadership team to turn on your cameras at this time. And as you do that, as folks can see, there's a lot of people on our leadership team, and I'd like to just thank everyone on our team. It's been a year-long effort to get here. So Jenna and Sade, our events directors, Evan, our judging director, Mike is our applicants director, Anthony, our director of mentorship, Aparna and Mung are our sponsorship directors, Sophia, Daniel, and Ashish are partnership directors, Kelsey, our marketing director, Chantal is the finance director, Quadri and Polkit are alumni relations directors, and Monica, who you've seen already today, who's the managing director alongside me. So as you can see, it really takes a village to pull this off. And we found out about 6 weeks ago that we wouldn't be able to do the in-person competition this year. And it's a testament to the strength and the talent of this team that we've been able to pull off this ceremony today in collaboration with all the partners I mentioned earlier. So now we are going to announce the runner-up and the winner of the 2020 MIT Clean Energy Prize. So I would like to ask all of the teams now at this point to turn on your videos, and I'll give you a second to do that. All right. So I'm delighted to announce, and actually I should say, you're going to have a cheering gallery from the CEP leadership team. So folks on my team, if you want to take yourself off mute, get your cheering voices ready. I'm delighted to announce the runner-up of the 2020 Clean Energy Prize at MIT is Harmony Water.
Let's go.
Well, congratulations to Harmony Water. You've taken home a $10,000 prize as runner-up of our 2020 Clean Energy Prize. We wish you the best of luck moving forward. Thank you for participating in this competition. And now we are going to announce the grand prize winner of the 2020 Clean Energy Prize at MIT. The winner of this year's prize is Nitricity. Nitricity, you've won the $100,000 grand prize, features on the My Climate Journey and the MIT Energy Initiative podcast. Congratulations. Maybe Nico, could we ask you just a quick second here, any brief thank yous, and tell us what's next for Nitricity?
Yes, sir. Could you please flip back a slide so I could take a picture of it and send it to everyone?
Let's see if that's possible.
Well, that's all right. I'm happy to answer some questions too. We're extremely grateful. This is incredible.
Wonderful. So, so just give us a quick sense of what's up next for you, and then we'll move to wrap up the competition.
Absolutely. So for us, we're spending a lot of time in Central Valley right now. This prize is going to have an immediate climate and company impact, as it's going to help us put systems in the soil in the Central Valley. And every system that goes down produces fertilizer without carbon. And it's something that our team is extremely passionate about. And this is, especially right now, this is just incredible. So we're very grateful for the opportunity, and thank everyone very much for making it happen.
Awesome. Well, congratulations. Congratulations to all the teams, and I'll reemphasize for any of the attendees, if you would like to reach out to, connect with any of the teams, and you would like us to facilitate that, please shoot us a note. Our email will be up on the next slide. And so with that, we are going to sign off for today's finals of the MIT Clean Energy Prize. Thank you so much for tuning in, and stay well, everyone, and please be in touch.